Okay, last time we talked about normal probability problems, right? We learned how to find normal probabilities if we either had information about the mean and standard deviation of a regular distribution, or if we had a standard normal distribution. So just to bring that back, normal CDF is used when you are given Z or X and you need to find the area under the curve or a probability. And it goes from low to high for a given mean and a given standard deviation. So for example, the last one we talked about was an application of the normal curve where it said the amount of time it takes for a pizza delivery is approximately normally distributed with a mean of 25 minutes, which means mu equals 25. And a standard deviation of 2 minutes. And we need to find the probability that any randomly selected delivery time would be between 25 and 27 minutes. And that it might be less than 22.7 minutes. So I've written those down. And even though we're going to use this, I'm going to move it off to the side for a minute. So this says that we have a normal curve. And the mean is always in the middle. That's mu. In this case, mu is 25. And the standard deviation of 2 says that if I go down 2 below 25, I'm at 23 minutes. And if I go down one more standard deviation, I'm at 21 minutes. And if I go down one more, I'm at 19. And it also says that if I go up 2, that's 27 minutes. And I'll go up 2 more, which is another standard deviation, that's 29 minutes. And if I go up one more standard deviation, which is 2, I'm going to be at 31 minutes. And just a review of what we should know, 68% of the pizza delivery times are going to be between 23 and 27 minutes. That's the mean plus or minus 1 standard deviation. And if I go to standard deviations, between 21 and 29 minutes, I'll have 95% of all the delivery times. So a delivery time that took longer than 29 minutes is only going to happen about 2.5% of the time. 2.5% because this 95% says that half of the remaining 5% is the area that's above 29 minutes. And it says it would also be highly unusual to have a delivery time that is less than 21 minutes. But I would consider both of those to be very, very unusual. So these are the ones that come from the range rule of thumb. That says that it's unusual to have anything outside the interval of the mean plus or minus 2 standard deviations. That's that 95% rule. And then the last one says that virtually all pizza delivery times (99.7% of them) should be between 19 and 31 minutes. So if you had a delivery time less than 19 or more than 31 minutes, that would be almost impossible. It shouldn't happen under the normal circumstances. Okay? Now to take what we learned on the calculator, the first one asks us to find the probability that a delivery time is between 25 minutes, which is right here, and 27 minutes, which is right here. And that probability, being from 25 to 27, I would find by saying normal CDF and going from a low of 25 to a high of 27 with a mean of 25 and a standard deviation of 2. And then round that off to 4 decimal places. So that would be 0.34134. And since this is where I would look to determine what my rounding is, then that would be 0.3413 or 34.13%. And that gives us the probability that X is between 25 and 27. That's the correct probability notation. And that would be exactly the same thing as saying find the probability that Z is between 0 and 1, because here our Z-score is 0 And one standard deviation above that is where 27 is. So the only difference is we're talking in terms of z-scores, and we would enter it saying normal CDF. Zero, comma, 1, comma, 0, comma, 1. Low, high, mean, standard deviation for a standard normal. Knowing that the standard normal curve has a mean of 0 and a standard deviation of 1. So if you put this same exact thing in, you're going to get 0.3413, which we're going to round to 0.3413, or 34.13%. So there's absolutely no difference in those two things. What a z-score measures is how far from the mean you are in terms of standard deviations, using your standard deviation as the ruler, so to speak. Okay? And the other one that I put up here, what's the probability that it's less than 22 minutes? Okay, down here we have negative infinity, and we refer to that as negative E99 or negative 1 E99. 22 is about right here. So we are at 1 1/2 standard deviations. That z-score would be negative 1.5. You could calculate it if you wanted to. Using that formula. So the probability we're looking for here is this area right here. So that's going to be normal CDF from negative infinity, negative 1 E99, to 22 with a mean of 25 and a standard deviation of 2. And that probability is very small, 0.02275. So when we look at the next number after the 7, it's a 5. That means we'll round up. And call that 0.0228, or 2.28%. So that's where we wound up last time. Okay? Now we're going to learn nutrit. So we're on the last page of the notes. We're going to talk about something called the inverse normal probability distribution. Now, when you see the word inverse, you can kind of think about the word reverse, which means we're going backwards. Okay? In this case, we're not going to be given the z-scores and asked to find the probability. This time, we're going to be given the areas. So given the areas and trying to find the z or x value, depending on whether it's a standard normal or if it's just a normal distribution. And we're going to use this part of the calculator, second vars, to get to your distributions menu. And this is option number 3, inverse norm. So going second vars, we're going to go down and we're going to choose number 3, inverse norm. Same menu, different option. So on the first one it says find the indicated z-score. And all of these say z-scores, so you need to remember that the mean is 0 and the standard deviation is 1. Now when we do inverse norm is always going to be the area to the left. 0.9900. So the z-score that separates the top 1% from the bottom 99% is going to be found by putting in the 99% that's on the bottom. So we're going to use the command inverse norm. And the first thing that we have is an area or a probability, and then the mean and standard deviation. And in this case, the area that's on the bottom is going to be 0.99. So we'll choose that command, put in the 0.99, and then the mean of 0, the standard deviation of 1, close the parentheses and hit enter, and that z-score is 2.326. And since we actually only want to round it to 2 decimal places, then that z-score is going to be 2.33. And it's important to notice that it's positive because it's above the mean. Yes? It's also defined in X tag, like a pizza delivery time. But it's defined the value itself, not the probability. The probability is going to be what you would get. Okay? Yeah, if you're finding probability, it's normal CDF. If you're given probability, it's inverse norm. Okay? So for problem number 2, we're given a little bit of a different situation. Because in problem number 2, it says the area between this negative z-score and this positive z-score is 0.7841. So if this is 0.7841 in between here, then the area out here is 1 minus 0.78, I think I said 41, but it's 1.4. So it's 1 minus that, but it's cut in half because half of it's going to be up here and the other half's down here. So 1 minus 0.7814 is a total of 0.2186. But only half of that 0.2816 is in the lower tail. Half of it's in the upper tail. So the part that's in the lower tail is 0.1093. So when we do this one, we do, again, inverse norm. We put that area in because it's the area to the left. And the mean is still 0, and the standard deviation is still 1. And we're going to get a negative z-score because it's an area that's less than half. And the z-score is negative 1.23. But this z-score is the exact same thing except it's positive. And that's because of your symmetry rule about the normal probability distribution.
Would it be okay to put that answer as z equals negative 1.23 comma 1?
That'd be fine. You don't have to put the positive sign. So once you've got this one, you know the other one. Okay? And then on our last one, it says the area between the two z-scores that we're seeing is 99%. So if there's 99% between there, how much is in here? 0.005, which is half of 0.01. Which means that same 0.005 is also on the other end. Okay? You're just taking 1 minus 99% and then dividing it in half. So the mean of this thing is still 0, and we're looking for a negative z and a positive z, with the difference being that instead of using this command, we're going to use inverse norm. Zero 0.005, 0, 1. And so that z-score is negative 2.575. Which gives us that z then is equal to negative 2.58 and positive 2.58. There's both your answers. Okay? And the next thing we're going to do is an application of z-scores, but it's not really a lot different from what we just did with z-scores. It says the verbal SAT test has a mean of 500. And a standard deviation of 100. and it says they're normally distributed, that means it's gonna fit that bell curve. And a major university determines that it's only going to accept students that are in the top 4%. Only the top 4%. So, it says what is the minimum score that a student has to earn to be accepted? The way we figure that out, just gonna draw my normal curve here. Where's my top 4% gonna be?
That last little.
That little bit up here, okay? That little bitty bit up here. But we have to have the area to the left. We can't use this one. So we're gonna have to use the bottom 96%.
That's what I was gonna say, can you do the one minus inside of it, or do you
Mhm.
have to do it?
You can do it,
Put it in the calculator before you do it?
you can do it within the command. I'll show you both ways. So we know that what's down here is 1 minus 0.004, which is 0.9, or not 0.004, sorry about that. 0.04, which is gonna be 0.96. Okay, the area that's to the left is 0.96. So we can either say inverse norm, .96, comma, and we're gonna use the actual mean, which is 500. And the actual standard deviation, which is 100. So that means one standard deviation up is 600, 700, 800. And what we're gonna get is the actual score, which we can see is gonna be somewhere between 700 and 800. And the other way you can do it is INVNORM and say 1 minus 0.96. You're still going, or not 0.96, 0.04. 500, 100. And the calculator will actually do the arithmetic for you. So if you've got the area to the right, you need the area to the left, just put 1 minus the area to the right. And that would be a score of 675.06.
Thought it was supposed to be 0.7.
Well, that's because I misjudged where that was. Because the z-score, and see, that's why it's sometimes a good idea to label your curve before you try to do the problem. The z-score for the 675 was actually 1.75. So I was wrong about where it was. It's more like that.
It's good to draw and do the calculation though, because
You catch mistakes. You will catch mistakes if you'll actually draw a picture and then do the calculations on the calculator.
Did you need to put an extra A in there?
No, I meant for that to not be an extra eight.
Okay.
But it's not gonna change the z-score a lot to have done that, okay?
So is it okay to run your answer? Because I just put.
Well, that was what I was about to ask y'all. is somebody, if they only take the top 4%, and this is actually the dividing line, what do you have to make to be in the top 4%? 676. You actually can't be at a 675. They're not going to take you. Because SAT scores and ACT scores are only given in whole numbers. So even though it's only just a little tiny bit more than 675, then realistically speaking, you'd have to have a 676 to get in if they took 4%. Okay? And on the one hand, those of us that are sitting there with our 675 say, well, I only like just a little bit, but they have to draw the line somewhere. So they drew the line at 676. Now, when you're doing problems in Pearson, I will tell you this, read their rounding instructions. Realistically, if you're doing it for me, and you tell me it's 676, I'm gonna be fine with that, because I wanna see what you got there from. I wanna see this answer first. Then you tell me in a sentence, you would have to make a 676. But in Pearson, they may tell you round to the nearest whole number. Now, technically, that's wrong, but that's programmers. Okay? So the actual answer to the question should be you must make 676 on the SAT verbal to be admitted to that school. And we've got some more examples, but since I've limited myself, because I just printed out what you had for notes, I'm going to actually pull a sheet of paper down here so we'll have a little bit more room. And you've got the problem written out in front of you, so what I write on here should make sense to you. So we have a pediatrician, and that pediatrician obtains the heights of her 200 3-year-old female patients. Now, if she only has 200 patients, then whatever she finds out is from her population. And it says these heights are normally distributed with a mean of 38.72 and a standard deviation of 3.17. So that means her normal curve looks like this. The mean height is 38.72. That's where Z would be 0. And that's not anywhere near dark enough for you to see well, so you dig a darker pen. So 38.72, and the standard deviation is 3.17. Now, I'm going to show you a quick trick to label your curve. I'm going to clear off my screen, and I'm going to enter in the mean, 38.72, and I'm going to start at the top end of the curve. Up here at the Z-score of 3. And I'm going to add 3 times the standard deviation. And so that top score is 48.23. And now I'm going to subtract 1 standard deviation. And I'm down to 45.06. And then I'm gonna hit enter again, and it's gonna subtract another standard deviation, 41.89. And there's all the rest of my curve labeled in. All I have to do is keep it hitting enter. So one standard deviation below is 35.55. Two standard deviations below is 32.38. And three standard deviations below, where z is equal to -3, is 29.21. So there the whole curve is labeled in. And then the question they give us, it says, what percentage of the 3-year-old females have a height that's less than 35 inches? Well, here's 35.55. Here's 38.72. 35.55 would be just a little bit below one standard deviation. So there's your 35. And the area that we're looking for, or the area that we're given, is that area right there. So in order to find that area, because it said what percent, we were looking for area. Then we're going to do normal CDF. We're going to go from negative infinity to 35 with a mean of 38.72. and a standard deviation of 3.17 to find that area. So that percentage is 0.12029. Which is 12.03%. And if you write that as a probability, and that's the way that you would write it. Or if it says to answer in a sentence, then you'd say 12.03% of her patients are less than 35 inches tall.
On the test will it tell us like how to write it?
Whether it be a decimal or a percentage.
Or like a
I usually will, I'll mention in the directions, answer the application problem in a sentence, or I'll put in parentheses after the problem, answer in a sentence, please. But if you're just writing a probability, I say, what is the probability of that? You just write the probability statement. Okay? Does anybody have any questions on that one? Okay, let's look at the next one down then. Next one down says, compute the probability that a randomly selected 3-year-old female patient is between 35 and 40 inches tall. So we have the same curve. So if you've labeled in your curve like we did in the problem before, and we want to know that she's between 35 and 40 inches tall, here's 35, 38, 41, so 40 is probably along about here, or somewhere thereabout. And what we need then is probability, since we're finding the probability is again normal CDF. (35, 40, 38.72, 3.12. And that should get us the area between those two heights. So that's going to be 54.26% or 0.5426. Rounded off to 4 decimal places.
I have a question.
Yes.
Where did you get the 3.12
From the original problem. Right here. Oh, I'm sorry. That changes things. Thank you. I have another bonus point I had to make a note of. $53.65. That should have been 1.7. Okay? Any other questions? And notice it didn't make a whole lot of difference, but it did make some difference. So you got to watch your standard deviations. Okay, still going with the same problems. It says find the z-score such that the area to the left of the z-score is 0.32. Now this time we're just talking about z-scores. This doesn't go along with the last problem. And 0.32 is about a third of the curve. So maybe somewhere like along there. And since it's less than half, then it's below the mean of the z-scores, which is 0. So we're going to use inverse norm. Right? Yes, inverse norm because we're given area. And the area to the left is the 0.32, and the mean is 0, and the standard deviation is 1. And we're expecting that that z-score should be negative because it is below the mean. And it's negative 0.47. You can always round your z-scores to 2 decimals. And then the next one says find the z-score such that the area to the right of the z-score is 0.4332. That's not quite 50%. So it'll be to the right of 0. But since this is the area to the right, then we're going to do inverse norm and need the area to the left. Now we could just go ahead and subtract 1 minus 0.4332, or you could put it in here as 1 minus 0.4332. The mean is 0 and the standard deviation is 1. And that z-score is positive 0.17. So that's that z-score right there. Okay. Now I'm going to stop talking. I'm going to let you work with the people close to you. Or if you just really want to work by yourself, you can work by yourself. But remember, 2 heads is better than 1, 3 is better than 2. Work together. And I want you to do the practice test review that I gave you. Now, this is not your complete test through review. This is just something you do in class. And these are all multiple choice. So that way when I post the answers, all I'm going to post is A, B, C, D answers. But you'll be able to check yourself, and I will post those by this evening. So I want you to check these. But I want you to go ahead and work them while you're still in class, and I'm here to help you.